Slow enough. We have bright field, we don't have phase, and you're going to get to use phase out at the clinical. Sometimes mucus is very hard to see. So remember, if you have stained, you want your light brighter. So you want to open your diaphragm, put up the condenser as close to light source as it can get to the stage. And we're going to try one stained, and then I want you to take the same urine. We're going to make sure we aliquot some. And I want to try it unstained. So I think what I'll have you do is we'll pour one tube that we're going to stain, and then we'll pour a second tube that we're going to show you the difference of unstained. I did stained urines my whole entire career because I liked when my white cells would take up stain to kind of differentiate from the red cells usually don't. But someone from Children's, and I would just go with her, she said, you got to get past that stain. Everybody's doing unstained. So last year we only did stain initially, and then we went to unstained. Because probably 90% of the people, I don't think Diane or Barb use stain. I use stain my whole career. So I'm going to show you that tomorrow, but I also want to show you the same urine unstained. And just like hematology, you got to look at the characteristics. You got to concentrate on what that cell or piece of sediment, what characteristics does it have. You got to concentrate on knowing the characteristics, not just having to have a perfect picture. Because it can vary what's out of a book versus what's for real, and depending on how old the specimen is too. So tomorrow we're going to start with lab so we can have first morning. So if you don't have a cup, bring one with you. I'm going to actually try to play around. Diane said the overhead scope was working fine, but I'm going to do my own urine this afternoon and play around with it while she's here. Because the guy came when he did our scope and gave us some tips, so I want to make sure. Well, so this is my goal. Every time we do urines, we'll do one together on the board. Now the magnification is higher. We do 10 and 40, but it's hard to get it to look like 10 when you blow it up. So ours more look like our 10 almost looks like 40, and our 40 almost looks like 100 when it's up on the screen. But at least you give a little idea of enumeration. And if you want to write this down, you're going to have a homework assignment for next week. So by next Tuesday in lab, no, next Monday, because we're going to have 2 6-hour days, you've got to do, and this will already be your MTS done for the semester, you've got to do the microscopic part of the MTS. So in order to take the test, you're probably going to have to look at physical, chemical, and microscopic. It has some great samples of every cell and enumeration of like plus to 4+. So if I assign it as a homework, it's also going to benefit you since we're just beginning microscopics this week. I think your knowledge base will have improved because we'll do 2 days where we'll do some. Then you'll do the microscopic and take the urinalysis, so you have that done for your portfolio. And then it should benefit you as I start bringing more and more hospital specimens. So tomorrow we're going to do our own, and then come Thursday, I'm going to go to the hospital every time we have lab and get real specimens that, hopefully we'll have some stuff. Problem is, it's hard to get all the pathological stuff because they don't even have a lot more than white cells, bacteria, maybe hyaline cast, granular cast. It's not easy for me even going to the hospital to get every kind of abnormal thing you could possibly see. So it's quite different from hematology. Things don't keep either. So the best you can do is get them as fresh as you can by your lab day, and then they deteriorate.
Do you have cups for us?
Yeah, we have a whole thing of cups up too, so before we leave, because I want to do a urine myself to play with this afternoon. Okay, so let's go through the reactions. Remember on the chemical, there were key things, and let's see if you remember anything. I know I'm not saying you've studied them at all, but let's go through to see if you retained anything without looking, okay? So we're going to just go in order that we had them on this sheet. What were the 2 indicators that I had you know for pH? Methyl red does for the more acidic. And remember the BB hint I gave you?
The bromine blue.
Bromthiamyl blue goes with the basic, the more alkaline pH. So I don't know how to help you with the methyl red for the acid ones. The protein, does anybody remember what they flag? They call it the protein error of indicators, but all I'm having you know is a key indicator for protein. It has a P in the name, so it's tetrabromophenyl blue. So we have methyl red, bromthiamyl blue for pH. And then for protein, we have the indicator as tetrabromophenyl blue. Glucose, there were two different ones, whether it was glucose or whether it was the Clinitest. And remember, I'm not giving you the name so you know, oh, it's glucose such and such. I'm just giving you the piece that's a part of it. Anybody remember? Oxidase is the dipstick. And what do you remember about that dipstick? What does it do? Only glucose or a lot of other sugars? Only glucose, that's a big deal. Then the Clinitest, you need to know two names that would be in its reaction, because they're two different. So there's two choices you'll see in registry questions. One is the one with the B and one with the C. Sometimes copper reductase, and the other one, sometimes they call it Benedict's reaction. That goes with the Clinitest. So tell me, how does the Clinitest differ from the dipstick? It does all, they call them all reducing substances. And a common one is like a lactose or galactose. If a baby had a lactose intolerance, it would show lactose in the urine, which would be detected by the Clinitest, but it would be a negative dipstick. That's why a lot of places, ours at St. E's was any child less than 2, you had to do the Clinitest, even if the dipstick was negative. So you need to understand that. What was the other thing? What was the common disease state you associate with high levels of protein, 100 or greater? What's a general disease you associate high levels of protein? Kidney. Okay, we'll get into more specific kidney diseases come Thursday. But you, as a general indicator, tell me 2 other proteins though that albumin's the main thing detected on the dipstick. What are 2 other proteins that are the doctor has to be aware and order other tests because they're proteins that could be in your urine?
Myoglobin?
That myoglobin goes with the blood. So what about if you have diabetic nephropathy? Remember what protein? Microalbumin. That is a test that has to be specifically ordered by the physician. A lot of times they have a little test that they can do strictly for microalbumin. And there was one that's associated with plasma cell dyscrasias. Again with a B. And you had to do something with heating. Boiling it. Bence-Jones. So you will learn that again with serology. Bence-Jones protein isn't detected on the dipstick. But if the doctor suspects it, he'll order the boiling test basically. And do you remember when the Bence-Jones proteins precipitate out and then when they disappear? You got to know that.
100 is when they precipitate, when they go back.
Right, 40 to 60 degrees, they precipitate out. And then you keep boiling it and it gets to 100, then they're going to dissolve and go back in solution. Okay, those are 2 tests you got to be aware of. The doctor has to order the Bence-Jones test, but microalbumin, you should see that in your chemistry department being ordered when you go on clinical. So glucose, tell me, what do we mean by the pass-through phenomenon? So it goes all the way to the orange, which is like a 4+ or the highest, and then it comes back to less normal. And then what do you do to correct it so it's accurate? Or not?
Natural milk.
How many drops do we do normally?
2 drops.
2.
We do
Okay,
5. We do 5
so we do
normally.
5, so you drop it to a 2, and then it should just go to the orange and stay. Oh, and so tell me the 2 confirmatory tests for protein. We skipped those. One, you just look for the milk line and you grade it. The other one has levels of cloudiness. Roberts is which one?
The line.
The milk lines, you grade it. And then which
Sulfosalicylic
one has the
acid.
levels of cloudiness?
3%
And
sulfosalicylic.
sometimes you'll just see it as 3% SSA, sulfosalicylic acid, and you'll see it as 3% SSA. So tell me then, what is the reaction for ketones? And it's the same for its confirmatory test, the acid test. One keyword begins with an N. Nitroprusside. So far we have methyl red, bromthiamyl blue for pH. We have tetrabromophenyl blue protein. We have oxidase for glucose. Now we have nitroprusside for ketones. What disease does it go hand in hand with glucose?
Diabetes.
Diabetes mellitus. Tell me on a case study what else you're going to see with diabetes mellitus that'll give you a clue that you might have glucose and ketone spilling.
Heavy.
High specific gravity, then you have your glucose positive, Clinton test positive, ketones positive, acid test positive. Nothing under the dipstick. The only thing you might see because you have sugar in your urine, if you have any bacteria from your skin because it wasn't a clean catch, that bacteria will multiply and it'll eat up that glucose to do so. That would be what you could see, but if it's a good specimen and that any bacteria was washed off before you collected the urine midstream, you shouldn't see anything under the microscope. Okay, so now think apply everything we learn, apply to a real person, because it doesn't help if you just learn facts. You gotta learn to see how it fits a person. Okay, so that's nitroprusside. Name the 3 ketones. You get 2 with an A, 1 with a B. So there's acetone, acetoacetic acid, and beta hydroxybutyric acid. So those are the 3 ketones, okay? Bless you. Blood. Now we'll get to your myoglobin. So the reaction is peroxide, or peroxidase, sorry. So, and then we'll build and then we'll go repeat them again. So we have peroxidase. And what 3 types of blood can you see on the dipstick? Hemolyzed, which could be which 2? Hemoglobin or myoglobin, and then intact or whole or fresh red blood cells. Do you remember? I don't think you're going to see many just pure red urines. A lot of them are just going to look yellow or darker yellow, but just you remember when it's hemoglobin or myoglobin, what would be the clarity of your urine? That's key. So the clarity, clear. And then intact red cells, when they really are the whole red cell, is cloudy. Once the red cell is lysed and it's hemoglobin or myoglobin, it should be clear. Just like if you look at a blood specimen, that hemolysis, it should be clear brown or whatever, the hemolyzed red cell. That's a big clue, the cloudy or the clear. And give me an example of what the case study could say if it was going to be fresh red cells. What would the patient have?
Trauma.
Trauma possibly, maybe a car accident, trauma to this area. You could even have menstruation if it's a girl, wouldn't have to be pathological, of childbearing ages. Some people on running a marathon, too strenuous of exercise. Some people even have severe dehydration, might have some blood in their urine. What about hemoglobin? What'd you learn in hematology? You got cold and warm. But you would have hemoglobin present in the urine. Hemolytic
Anemia.
anemias. okay? And then myoglobin, like if someone who had trauma could also have, if there's any muscle damage, could also have myoglobin in the urine.
Is that
So you-
also the heart attack?
Heart attack would be a muscle trauma, could have myoglobin. So anything that would release the myoglobin from a muscle damage. Now,
Like the car accident, sorry. You
Could
the
have
whole
both.
blood and the.
it could have both, especially if there's any muscle trauma. Tell me, how do you confirm if it's fresh or intact red blood cells? Where should you confirm them at? Under the microscope. But the longer urine sits and the more alkaline those red cells will deteriorate. So even if I get urines at 6:45, by the time we do them, let's say at 8:30, you're going to already have lower values than was at 6:30, just from sitting around. But what would be the test that you can do to distinguish hemoglobin versus myoglobin? You gotta know this confirmatory test. It's a chemical reagent. Ammonium sulfate. It'll absorb out the hemoglobin, and the myoglobin, when you centrifuge it, would stay put. And then when you did the dipstick, if it's positive still, you know it's myoglobin. If it's negative, you know it was hemoglobin and all that was trapped in the ammonium sulfate. So, bilirubin, so we have peroxidase was for red blood. Bilirubin begins with a D. 5 letters. Diazo. It's like a diazonium salt, and they call it a diazo reaction. And bilirubin is the breakdown product from hemoglobin. And normally it's made water soluble, and it goes through the intestine and becomes urobilinogen. So normally bilirubin is processed all the way through and goes out in your feces. It's the urobilinogen that some of it recirculates to the kidney, and we see that. What is our normal for urobilinogen?
0.2.
0.2 to 1.0. There's always some that recirculates and goes out through your urine. So when you have an obstruction, bilirubin is not going to be able to get through and become urobilinogen. So you have bilirubin backing up in your bloodstream, it spills into your urine, you get jaundiced, you have enzymes that go up for bilirubin in your chemistry test. So if you have an obstruction where it can't be made water soluble, urobilinogen, the time it strictly goes up only by itself and bilirubin is normal, is on your hemolytic anemias. Bilirubin just keeps being conjugated, goes through to become urobilinogen, and the urobilinogen increases and more recirculates and goes out. So if you had hemolytic anemia, you would have like a 4 or an 8 urobilinogen instead of a 0.2 or a 1. The only time they kind of are both elevated is if there's a liver disease like a hepatitis. So I think I'm having you on your test. You got to know the bile duct obstruction or increased bilirubin only, and you have to know hemolytic anemia, increased urobilinogen only. Okay, we're going to streamline to that. So what is the confirmatory test for the bilirubin? The icto test. And that's the one, if we had any more tablets, we didn't order them though, because no one's hardly doing any, so we weren't going to spend the money to keep ordering them in. The pad gets the urine put on it. Everything absorbs through the pad, except the pad will hold up on top bilirubin if it's present. Then you put the ictotest tablet with water, and you do 2 drops of water, and if there's bilirubin, it makes the dark blue purple ring. Okay, so that is a confirming test. Urobilinogen, the confirming test is Airlix, and I think it was the last PowerPoint slide that had a picture of the Watson-Schwartz. Remember, the Watson-Schwartz can detect either urobilinogen or porphobilinogen, because that's also a breakdown product that can happen with bilirubin being broken down. And some people with a disease called porphyria, like lead poisoning, you could have porphobilinogen as the excess, not urobilinogen. So which test was the confirming test if the doctor only wanted to see if there was porphoblinogen? That's the other one you gotta know. And it's HESH, okay? So you gotta be aware that you need to know both. And then the two that go hand in hand for UTIs, which are which two? Nitrates and leukocyte esterase. So it's like a name of the man, the reaction you gotta know for nitrites begins with a G. G-R-I-E-S-S, grease, okay? And then the leukocyte esterase is leukocyte esterase, but I just have you know esterase. What white cell does the leukocyte esterase detect? Which one? Lymphocytes? Monocytes? The neutrophils, the granulocytes, okay? So it only is and usually that's what's fighting a bacterial infection are the neutrophils. So how do you confirm the nitrites and how do you confirm the leukocytes? Microscope. Tell me how you can have a negative nitrite with a positive leukocyte esterase, and it's good, and they have a UTI.
Gram-positive.
Gram-positive bacteria. One you'll run across in micro that will do is Enterococcus, Streptococcus, Staphylococcus. Those are all gram-positives. So you can have a UTI, and at St. E's we had a rule. If it was greater than 8 white cells per high power field, we automatically sent off for a culture because they suspected a UTI. A lot of labs will go by the number of white cells you report out on a urine, especially if it's a clean catch urine that was collected properly. Okay? So tell me now, what is a common false positive? There's actually probably a couple of them that cause a false positive commonly. Letting it sit too long, especially glucose would be one that would go down letting it sit too long because it'll be eaten up by bacteria, but your nitrites might be more positive. We had down for urobilinogen, nitrites, and protein and pH that were false positives. And the other thing are detergents, not rinsing out your container well enough before you collect the urine. And we had that, the leukocyte and the glucose. So I'll have a matching on the false positives and false negatives. The other thing for false negatives, a very common one is ascorbic acid or vitamin C. But those you'll have to look at them for a matching. And I'll do the reactions as a matching as well. Okay? So let's practice the reactions one more time in order. Try not to look. So we have pH, methyl red, bromthiamyl blue. Protein, tetra, brom, phenyl, blue. Glucose, oxidase, ketones, the nitroprusside, blood, peroxidase, and then bilirubin. Hey, bilirubin goes DE, diazo, and then urobilinogen is Airlix. Nitrites is grease, and leukocyte is esterase. The specific gravity, all you have to know is that it's the pKa, whatever's on your thing, pKa polyelectrolyte. If you see that on a matching, that goes with specific gravity. Okay. And then if anybody needs to take pictures today for your test on Thursday, you need to take it out of my graph, because the one in there is the older edition. I swapped them back for myself. So I have it with me, anybody who needs before you leave. Okay, so now we're to the point. We've done color clarity, which is part of physical. We've done chemical, which is part of the top part of your analysis. And we've confirmed the 4 things chemically if they need one. The glucose, the ketones, the bilirubin, and the protein. Now we get to the hardest step. Microscopic is the most tedious and the one you have to be proactive about. A lot of people have automated analyzers. You're going to have to say, I need to see a lot of manual dipsticks because we can't match what someone's going to have normal urine. You know, a lot of urine's coming in every day that are fresh. We can't match that. Even the best I can do is go there at 6:45 and get the best I can. So you have to be proactive and say, hey, when I'm on the urinalysis bench, I'd love to do as many urine microscopics as possible. So now we have to look at, so tomorrow when we start, we're going to look at low power field, which is 10x, and we're going to look at high power field, which is 40x. We don't use any oil until we get to body fluids. And we'll go back to using oil because you'll have to do body fluid dips. Every urine has to have these 6 things accounted for. You're going to have to look at your epis, and there's going to be 3 of them, if there's any mucus, and if there are any casts. And they have to be enumerated on low power field. Sometimes we go to identify the cast or the cells under high power, but it's only to identify them. Then we go back and enumerate them on low power. And then on high power field, reds, whites, and bacteria. So all of your reports in your syllabus that you'll start working on tomorrow has to have those 6 things accounted for, even if they're negative. If you have nothing but some squamous epithelial cells and some mucus, then I have to see N or a dash on all the rest of them. Every urine has to have that accounted for.
I don't really understand what a cast is.
But we're not there yet. Yes, it's protein that solidifies in the renal tubules in the shape of a cylinder with rounded ends, but we're not there yet. But I just want to make you aware, every time you do a urinalysis for me, you have to have those 6 accounted for. And you want to do as many as you can. Anytime we even have body fluids, you're still going to have 4 urines that are potentially due that same day. Because we've got to do, that's why I don't like this class to get done too soon. 7th week will be fine because I want you to do urine microscopics up to the time you go to clinical. Because it's tough to get good urine microscopics. So I need to take a chance of each week maybe having some good ones that I pick up at a hospital setting. Okay, so that's where we're headed and that's our goal tomorrow. My goal tomorrow would be to do your own urine and one other person's urine. So now we have to spin the urine. You want to have everything done that that needs to be done before you spin it. We call it centrifuging. Normally blood is centrifuged at 3,000 RPMs for 10 minutes. You're going to see these neat things called ultra centrifuges at the lab that might spin the samples in 2 to 3 minutes. They're wonderful because you can spin them and not waste so much time processing. Ours is the old way, so it's going to be the full time. And I'll teach you how to decant. Decant is, so you'll have your 10 to 12 mils of urine. Then when we're done doing everything to them on the top portion of the urine, we'll go to the sink and usually you do one quick pour like this and you should have about 1 mil left. There's a neat system called COVA system, but it's very costly, so not every hospital will use the COVA system. That comes with a pipette that comes into the tube, and when you pour over, it leaves a perfect mil. So that the goal would be to say, well, shoot, every one of our samples has 1 mil exactly. We know we're going to have very good results. They'll be consistent because we have the same amount poured off every urine we do. I don't know if you'll all see the COVA or not out there. I have a COVA slide we'll try one of the weeks. You can plate 10 urines at once. But I think when we're first starting, I found the students do better if we do 1 urine at a time under the cover slip. And then I teach you a way to scan the edges and cut through the center. But the COVA slide, we will try that. But you got to be very good with identifying your wells and making sure you're on the right urine. So I plate all my 5, and then I keep my urines in the order that they're on my COVA slide in the rack. So I knew if I was on well 1, I'm that urine. You gotta know, when you're doing slides, that there's not a really easy way to write on the slide because they're pretty small. And you gotta find a way to identify it that you know you're not messing up and calling the wrong urine, okay? But this COVA system is probably the most beneficial system where you are consistently pouring off the right amount. This, and you have to vary per site. When I was at St. E's, we were St. E's, then we became Trilab, even though we never changed area. We were still in St. E's Hospital, but we were called Trilab. Then we went back to St. E's. While we were at Trilab, we had 3 hospitals feeding into being Trilab, so we had to start calling our urines like Gateway called them. So we had to change the way we did them. We used to do plus, minus, all the way to 4+, and then we had to stop and go to few, moderate, many. And it was an adaptment, but it's still, you just adapted to whatever hospital they wanted as the main one for calling urines. I put how we called it at St. Elizabeth's in your syllabus. But you gotta be flexible when you go elsewhere. You may be calling them differently, how they enumerate. We'll have some, we give specific numbers. So if I tell you to give me the red count, you're gonna at least count 5 fields tomorrow. And if you have 5, 10, 5, 0, and 2, so that's 22 divided by 5 is 4.4. So you would find the range that 4 was in. One of our ranges are 2 to 4 red cells per high power field. Then they might go 5 to 10. So I always err on the side of the patient. This is the range I'm going to report. Okay? So tomorrow when you're doing red cells and white cells, you've got to put your average down and then find a range that's in our syllabus, and then you put that range down. So you need to do that on reds, whites, and CAS we enumerate. CAS will be for low power field. So you got to get in the habit. If I don't know if that's a cast or what kind, you bring it to the center of your field. Then remember parfocal. If you're in focus in 10, you should be able to switch to any focus without moving the knobs. Just switch and just do the fine focus. You identify it, then you go back to low. And every field you look at on low is one field. So you got to try then to go find how many casts we're in. And if you saw that same number, you would have to say, and there was 2 to 4 as a range, you would have to say 2 to 4 hyaline per low power field. So you got to know what gets counted where, so you turn out things accurately. When we get to things like mucus, we call it few, occasional few, moderate, many. If I hardly see any, I might say a rare. But remember, only sweat the pathological stuff. Mucus is very common for girls. Squamous epithelial cells are very common for girls. If you miss them by 1 or 2 levels, are you hurting anybody? No. This is critical. CAS can be very pathological. Reds, whites, bacteria. So don't sweat the stuff that isn't as important, so you can really get good at what is important for disease state. Okay? So the numeration is a little bit, I'd say, frustrating, because it doesn't matter. I can send you to 10 different labs and they might all enumerate it a little bit different. So this COVA system, this is the little pipetter that comes, and then I have the slide, the 10 well slide. It's wonderful if you can sit there and have one slide, you have your 10 urines, and you just go, and then go, and then enter them and file them. So it is a time saver. But the key thing, remember, when we use a stain tomorrow on our first urine, it's called Sternheimer-Malvin is the common stain. Just like you had crystal violet, we'll have when we do our gram stains. You had your Giemsa or right stain when you had hematology. So different stains are used depending on what you're trying to get to view. But we're going to try them unstained for the most part. Tomorrow we will, probably this week we'll do stain and then let you look at the same urine unstained as well. Bright field is what we have in the lab. So the only way you can help yourself, and you saw that when counting manual reds and whites. If you didn't drop that light, you sometimes couldn't see those cells. I can't find it. Well, you had your light too bright or you weren't in a good area. If we do them unstained, you've got to drop the light. So close the diaphragm, lower the condenser, pull it away from the stage. So know how to use your scopes. When you get out in the lab, it's going to be wonderful. My scope at St. E's was great. You could do bright field and you could do phase on the same scope. Because sometimes I liked looking at them at bright field. It wasn't always that I wanted to do the phase, like darkens the background so things stand out. Bright field, it's usually a brighter, lighter background. So this, this is a bright field where I can see up here that there's mucus in the background. And it's very hard to see unless you drop your light when you're using a bright field scope. We have a lot of difficulty in lab seeing mucus because we have all bright field scopes. So we'll try to play around with our light tomorrow since that's what we have. Phase just makes things stand out. This is an example. We're going to talk about epithelial cells. There's 3 of them. Squamous are the biggest normal cell you're going to see. And women, sometimes you can look at a girl's urine and not know it's a girl, but know it's a girl. You think, uh-oh, I see a lot of squamous epithelials, I see a lot of mucus, I know this is a girl's urine. Guys don't have that much opportunity for a lot of skin around their penis to put the epithelial cells and to put mucus. They don't have the mucus production a girl does. So remember, when you learn something in class, apply it to what it means for a patient. You know, facts are great, but if you can't use them. So think squamous would be more with a girl's urine. There's one other one here called a transitional. And this is more epithelial cells that are like maybe in the urethra, in the ureter, not in the kidney. So that's the big thing. Transitional aren't bad either. And one of the things you gotta know, retain, is the transitional has a center or a central nucleus. So remember when I told you to study your characteristics? Without looking at a cell, you should be able to tell me characteristics so you at least can be thinking through a cell. Okay, does it have this? Does it have that? And the other thing in this field is a white cell. It almost looks like the size of the nucleus. I think actually this is the nucleus. These are 2 white cells on top. The other thing you start thinking is size. Just like in hematology, who was a bigger cell, your immature or your mature overall? What was bigger? Usually your immature are larger, especially in the case of a lymphocyte. You know, they get to be the size of a red cell typically. Well, you got to think that when you're looking at sediment. Your biggest cell is going to be the squamous, and that looks kind of like a fried egg, unshaped. Then you're going to have your renal and your transitional epis. The transitional has a center nucleus. The renal has an eccentric nucleus. We're going to get into some different types. Then your next cell is going to be a white cell. Your next cell is going to be a red cell. And then you're going to have these little light things called bacteria that are very hard to see, but they're minute. Once again, like hematology, you got to be knowledgeable. My biggest cell I'm looking at under low power is my squamous. My smallest is going to be the bacteria. Think of size. 'Cause you guys all easily say, oh, that has to be a white cell, oh, that has to be a renal, and you didn't even look at the size. So remember, you gotta know your characteristics. Anytime you look at a cell, know the characteristics. We already know with red cells, they don't have nuclei except when. They're nucleated red blood cells that have pushed out too soon. Okay, so phase is your friend. So it's one, and all of you should be able to get to see phase at clinical. This is stained. What I like about stained, these are all, this is just an artifact, which is like a clothing fiber or hair. Most of these are squamous epithelios. This one could be a squamous, but what type? If it was just based on central nucleus, you'd say they're transitional. But one of the things you'll have to understand about renals, they have eccentric nuclei or they have a high NC ratio. What do I mean by that? If they have a high NC ratio, you should know that from hematology. So the nucleus is very much most of the cell compared to the amount of cytoplasm. If I looked at a squamous, I'm going to say it has a low NC ratio. Little bitty tiny nucleus and all this cytoplasm. One of the things you learn with blasts, they have usually a high NC ratio, and the other thing you should have learned, they have very soft chromatin compared to the chromatin like of a mature cell like a lymph. So the same thing with urine. Some renals have a very high NC ratio, and the nucleus takes up most of the cell. This one still is not quite big enough nucleus, but if it was bigger than that, I'd have to go with a renal because it has a high NC ratio. So you've got to study characteristics that should be in your head without even looking at a picture. That should help you in identifying things. So when we go on low, we're going to look for all six, these three, and then the reds and whites and the bacteria. But where I'm at on the actual PowerPoint, I've added a third one, is I'm still working on the pathological crystals. When you're under high power, then you have a hodgepodge of anything else that could be present. So you might see yeast. Instead of just bacteria, you might see yeast. Instead of yeast, you might see a parasite called Trichomonas vaginalis. Depending on if there's a problem with the male reproductive organ or after sex, you could see sperm. If there are tons of artifacts that everybody thinks is something, oh my gosh, what's this in my urine? It's usually a hair fiber, it could be a clothing fiber. You're going to see big black circles that are air bubbles that you're going to think, oh my gosh, is that a large red cell or something? So you always also have to be aware of the crack. These are not sterile specimens. Well, they're not sterile slides. You got the little slide box, that's not sterile. So I would get in the habit of maybe wiping them off with a Kim wipe before you put your urine on. Get it out of the box, wipe it off, and then put your urine on. So all of those things fall under the high power that you're going to have to identify. And I don't know if you guys can see, and maybe if I'll turn the light off, it might look a little better. It is very easy. Let's see if I can get this to do it. It is very easy to have this cluster slough off on a woman's urine and have a big, like almost sheet of squamous epithelial cells. Now, the transitional is the center nucleus. And would you call this a high NC ratio? No, there's a ton of cytoplasm still. It's probably at least 2 to 1 cytoplasm to nucleus there. So remember, if it's a center nucleus and it's a low NC ratio, it is a transitional. The renals, and there are even some transitionals that can be a term called caudate. They call that C-A-U-D-A-T. They almost can look pointed ends or have a tail-like. So remember, squamous and transitional are not pathological. When it comes from the kidney, it's pathological, and that's why it's called renal. So you're going to see names renal, you're going to see RTEs, which is renal, tubular, epithelial. They're all the same thing. I might call them renal epies most of the time. You might see RTEs, you might see renal, tubular, epithelial, but these are the bad ones. They come from your kidney. And these, especially, this is one that has the high MC ratio. Do you see how this one is off to the side? And then this one, all the side, it's off to the side. This one's off to the side. This one is off to the side. They call that eccentric. So if they say they have an eccentric nucleus, that is renal. So maybe RE has the E with eccentric. I don't know how you can remember that transitional is central. But you got to remember this type too. That one has a large nucleus. It's pretty well equal to the amount of cytoplasm. So if it has a high NC ratio, it's going to be the renal, not the transitional, even if it's centered. So you got to look at that. Some of these, some of these are almost all nucleus. Those are all the nuclei. Look how big those nuclei are. So you got to be aware if it's a high NC ratio, you can have some misshaped, but you got to remember your characteristics. So if it's a smaller nucleus and it's eccentric, it's a renal. If it's high NC ratio, it can still be a renal, even if it's a center nucleus. A small central nucleus is a transitional. And the squamous are just big. They just look almost like a fried egg. The mesothelial cells, when we do body fluids, we kind of describe them as a fried egg as well, but that'll be in a blood or a body fluid setting.
What did you say about caudate?
Caudate is a transitional. I don't have a good picture of that, but they almost look like football shaped. And white cells, you're going to see a variety of things with white cells. This is magnified greatly. Your white cells under 40 are not going to look that big, but this is almost like 100 magnification on the board. But what do we know already about red cells versus white cells in a blood smear? Which one has the nucleus? Your white cells. So already these don't have nuclei. And on the scheme of size, we already know the red cells are smaller than the white cells. And the white cells, if you can't tell the lobes, they should at least look granular throughout. Red cells can be crenated, which you've seen when you've counted manual red cells. They can be ghost-like, and the lower the specific gravity is of a urine, they swell in a hypotonic urine, and they can become big and ghost-like. So your red cells can look different depending on if they've lost their fluid or they've swelled. But overall, they should be smaller than a white cell. And these, and your friend is your fine focus. Anytime you do hematology or urinalysis, your hand should be constantly using the fine focus that you don't miss things. Using the scope, you should never just sit there and never touch your fine focus. When you're doing a thing like a diff or a urine microscopic, you should have that focusing back and through to make sure you're not missing anything. And what's so good about the MTS that I'll have you do as a homework assignment, it gives you differences of a low amount to a high amount. It gives you case studies. It's a really good website for your analysis that in the beginning stages, especially after we have this week where you'll have a little background knowledge, it should really enhance you by the time we do more micros from the blood, the hospitals. All of us can have some, probably as a general rule, we're just going to say 0 to 2 reds or whites are normal. We can all have some. That doesn't mean that we're sick and have a bad disease. But Usually your white cells should not be see-through. They should be granular, even if you can't tell any lobes of the nucleus. You should focus through them and they are not see-through. Crenation is totally different. That's like little spiked on top edges, not through the cell. You got to get in the habit with hematology and any kind of microscope work with cells. Focus through it. Use your fine focus as you move your slide. Because you can be moving one hand the slide and the other one using your fine focus. Red blood cells, these have some ghost-like ones, and then you have the ones with the spiked edges, almost look like black dots on the outside. Remember, they can swell bigger as well if it's a low specific gravity. And I try to, we'll do slides, a few slides each week as part of your test. So starting next week, we'll start putting some slides on your test as well. And I'll always try to give you a slide that you can compare sizes, because this is a hard one. These are all red cells. I've looked at red cells a ton, and I know that. But there's nothing but red cells on there. So I'll try to give you a slide that has something to compare stuff to. Because it's better mentally if you can compare sizes when you look at your cells. Even like when we get in hematology, did any of you use your lymphocyte, your small lymph, as your guide for if your cells were normocytic? I mean, that lymphocyte should be the size of a red cell. So right there, if you have a typical normal small lymph with a little fringe of cytoplasm, you should look and see if the red cells are close. Even if you don't have your indices in front of you, you should be able to say, oh my gosh, they're way bigger than that, they're probably macrocytic. Oh my gosh, they're way smaller than that, they're probably microcytic. Remember, try when you're doing anything like a diff, urine sediment, try to use size to have of different things in the field with you. Once again, we'll go ahead and keep 0 to 2. First thing I think on a woman's urine is it might be menstruation. That is a very classic false positive that we're not going to sit there and think they have bleeding in the urinary system before you first make sure it's not menstruation that you have. And kidney stones, without having trauma to the urinary system, kidney stones would be another reason that you might have some bleeding. So remember, so far the squamous are looked at what field? Where do you enumerate them? On the board.
10.
Low, under 10. You might have to go to 40 and identify them, but you go back and enumerate them on 10. Where are white cells and red cells enumerated?
High.
On high. Now, crystals, this is the part I haven't finished completely on the PowerPoint. I'm making an additional one for you. You're going to have to know that normal acid ones, and if I give you a picture of a crystal, I'll always give you the pH. So you have normal acid ones, and you have normal alkaline ones. And in general, all your pathological ones are acidic. So the pH is going to be less than 7. You'll have to know that your acid normal crystals will be calcium oxalate and uric acid. And then there's this one catch-all thing called amorphous sediment. What I did in the sediment 3 slide I'm making for you, I put amorphous urates and phosphates, and in parentheses put sediment, because I don't have you distinguish. If the pH is less than 7, I don't have you call it amorphous urates. If the pH is greater than 7, I don't have you call amorphous phosphates. I just say know it as amorphous sediment. So you'll see I only have one slide for that on the new one. You'll get certain ones, the bottom row, are your alkaline. The pH is above 7. When you're a tech and you're going to call a crystal, you better look at that pH before you go call it. Because you can't be calling triple phosphates when their pH is 5. It is pH above 7. So there's triple phosphate, there's the calcium carbonate, and then there's this, they call this the thorny apple, they call this the dumbbells, they call this the envelope, or sometimes it looks like a coffin lid. This usually looks like a plus or an X through a square. Uric acid is varied. There's lots of different shapes it can be. So when I always tell the students, if you think you have calcium oxalate or uric acid, if it has the same shape and it looks like a plus or an X, it's probably calcium oxalate. If it's an acidic urine and it looks many different shapes all over the field, it's probably uric acid. So this is what I mean. You've got to study key things about your microscopic. You're going to be a much better person on the scope if you know your characteristics. Okay? And that's what you can do for yourself at the clinical. If you know you're going to be on urinalysis that week, you better study all your PowerPoints, go back and look at, I don't take you off right away Blackboard, so you have access to go on to urine, you'll have access, I don't know if you could get to heme, but you know you'll be able to get to urinalysis. Go review it so you come with your knowledge base. Know it, everybody's going to teach you more if you come prepared. Okay? And you got to take ownership. Even if that person can't hire you, you want them to have someone give you a good reference. So your goal is, even if you don't get a job where you're at, ask somebody, some tech to be a reference. Because we can only give you references from school, which isn't the real world. You need someone from clinical that can say, yes, they'd be great in your lab. We just didn't have a spot to hire them. The bottom, I don't have on my newest PowerPoint, I don't have these. The ones we'll highlight will be cholesterol. I always think they look like plates of glass. Cysteine is the hexagon shape. I always think the leucine looks like a snail or a cinnamon roll with its dry, and I always think the tyrosine looks like a thing of needles. So sometimes you got to think of little clues that, and it's a tedious process. I know it just doesn't happen overnight, you know. I know it's all like, oh my gosh, more things to remember cell-wise. But the more you do it, the easier it gets. And this is what, the urates are less than 7. You call them phosphates if it's greater than 7. I bet everybody's going to let you call it amorphous sediment. That's what we did. To me, you know, when you do a urine unstained, everything looks kind of like gray in the background. It just looks like someone just put a lot of junk on your slide, and it's dirty. So there's really, that's the term amorphous. It doesn't really have like a great shape or whatever. It just looks like a blob of junk. And so, a little clue, since most urines are acidic, tomorrow when you centrifuge your urine, a clue that you're going to have amorphous is if your sediment is pink. So when I bring them from the hospital, even though I try to go and get as fresh as I can tell when we centrifuge them if that urine was a little too old. It'll be a pink sediment. And I could probably see cells through here. It'd be thin enough. But you get big hunks like that, I would recollect. I'd say I can't even see the cells that might be pathological because the amorphous is too thick. And on their end, if you took it off the little elevator, we called ours the dumbwaiter, and you went and looked at it right away and it had this, they can't say it was fresh, that they sent it right down. You would not have this amorphous if it was fresh. So you are the tech. You can say, I cannot see even cells through all the amorphous. I need a new specimen, and I need it sent down right after it's collected. Not sit on their bedstand or in their bathroom for 4 hours before they send it down. This, you know it's not fresh. And it's your right, you're the one turning the results out. You don't try to guess or say, oh no, there was nothing there, because you couldn't see it. This is your most typical, and these are my favorite. I just think they're so cute. They just look like little plus signs or X's. And we should, tomorrow I would hope we don't see any if you all put it on ice, if you put it in your bag and bring it in, or if you collect it here. But I can probably guarantee on Thursday we'll probably see some calcium oxalates when I get them from the hospital. There's other forms. This is the predominant form. It's supposedly these other forms as well. I think 99% of the time you're going to see this form. But the big clue is it's an acid pH, so it should be less than 7. And these are squamous epithelials up in the top. Here I can't, this is an example of what yeast should look like. They link together, and there's like 4 right here. These are hard to tell if they're deteriorating white cells just because they look granular. They don't look crenated, they look granular. But they're normally, these look like the size of red cell. So I'd have to, on the reels, I'd have to focus through and see if they were granular throughout. Then the uric acid, this is the one, can have all shapes. This is probably the most common shape. This is very common. I don't know if, we had one urine that I got had a lot of uric acids from the hospital that was really good. But ask yourself the question, if it's less than pH, it's less than 7 and you know it's acidic, say, does it have the plus signs or the crosses in it and it's the same shape over and over and over, or do the shapes vary? If they vary, go with uric acid. That's usually a good, the varied shapes of uric acid, they're usually one common shape with the calcium oxalates. That should give you a clue. And these are normal. Are you hurting anybody? No. Remember, don't get so worked up about things that aren't pathological for the patient. You want to be good and not miss. Like if you're doing your diffs and you blow over a blast, that's a big deal. You know, remember, whenever you're doing your counts and anything, don't miss the pathological stuff. These are really cute too. They, I would say the most I saw, this one kind of looks like when it's turned on its side, this is like turned on the side, they kind of look like coffin lids. But most of the time you see them flat and they look like an envelope. So I think that's the most common shape. But what does the pH have to be? Greater than 7. Okay?
It's the Hershey's miniatures.
Yeah.
With the wrapper.
Actually, they
Just
do
like that.
the wrapper on the back side. So whatever it helps you, but what's your big clue? It has to be a higher pH. It can't be less than 7. They call this the thorny apple. To me, they look like little aliens. And once again, the pH would have to be 7, and it's a normal crystal. None of these are harmful. These are the dumbbell shaped. So they just look like little dumbbells. Like that's a good dumbbell shape. That's a little bit of a dumbbell. There's little clusters of them. That's a little dumbbell. Once again, higher than 7. So you have calcium oxalate, the plus or the crosses, and the carbonate. I don't know what helps you to put dumbbell with them. And then the liver damage would be the 2 that I'll have you know for me are going to be the leucine and tyrosine. So the leucine is the one I think of like the cinnamon roll or the snail, and the needle-like one is tyrosine. So have you did enzymes with Barb yet? What enzymes could be positive on the blood test before you suspect to see these in your urine? What goes with liver? There's one right there, bilirubin. What else? You had ALT, AST. Did you talk about ammonia? GGT. Before you expect seeing liver crystals, you better have some elevated liver enzymes. And you have a kidney problem, you would better see urea and creatinine on your blood panel for chemistry before you start seeing a lot of heavy protein and problems in the urine. Remember, a lot of things start going hand in hand the more you get through the classes. And then we'll talk about amino acid problems on Thursday. And cysteine is an amino acid that can proliferate, and it can even form a renal stone if someone has this amino acid problem and they're spilling out in their urine. They can even form a stone that could cause the blockage. It is the six-sided. So your pathological ones, the three for sure, cysteine goes with an amino acid problem, and then leucine and tyrosine go with a liver problem. So those are three of the pathological ones, and their pH of the urine should be acidic still. And cholesterol, you know, sometimes when you have fat processing problems, sometimes there's a disease that we'll get into called nephrotic syndrome, where the fats are broken down improperly and you have these oval fat bodies that'll show up in your urine. You might see cholesterol crystals. I think they look like plates of glass, flat plates of glass that can have little notches in them. And then sulfa is probably the drug I'll have put on a test. Someone on sulfa antibiotics may have crystals form in their urine from taking that drug. So if I ask you any drug, it's probably going to be the sulfa if you want to start that one. Now the cast, there's a protein called, I'd highlight that, you got to know Tam-Harsball. That's a protein that is in your renal tubules, and when you have kidney problems, you secrete too much of it, and it ends up solidifying and forming a cylinder. Usually, mucus and it can look alike, but your cast, look for rounded ends. Mucus can be strands and sometimes have pointed ends. But your cast, I always look for rounded ends because they can look very similar. They have this grayish consistency, the cast and the mucus, when you're doing an unstained urine. So the clue is, look at the ends to see they're rounded. They take the shape of your tubules. That's how they get the cylindrical form. The basis of every cast is what is called a hyaline. And the hyaline cast traps either cells, which then the cells, the longer they're in your tubules and not voided, can break down, become granules. And if you don't have good voiding, they call that stasis. The urine stays put, it doesn't get voided, and then the granular cast become these big, broad, waxy casts. So if you kind of remember, the main cast is the hyaline, and any other cast is a hyaline trapping it. The only one you can have that in normal amounts is the hyaline. So if we keep 0 to 2 as a common theme, 0 to 2 white cells are normal, 0 to 2 red cells are normal, 0 to 2 hyaline. I think you only have to word one little number then. So, if some of us, even in our urines, had a hyaline, that's not anything bad for you. But once it starts trapping stuff that you have excess, maybe excess red cells, and a lot of times the red cells, they deteriorate quickly and become hemoglobin cast, and you don't see the cell. But as a rule of thumb, for your career, don't call a cellular cast unless you can see free cells around it. I would not be calling a blood cast or a red cell cast or a hemoglobin cast if I didn't have high blood on my dipstick. The doctor's gonna say, you don't have any red cells, you didn't flag any blood, but you're gonna call a red cell cast? Or if you call a white cell cast, but you have no leukocyte esterase, they're not gonna believe you. And we're gonna learn Thursday diseases that a red cell cast goes with that is key, and a white cell cast goes with key. There's another disease we're gonna learn when there's a fatty cast. When you don't process your fats properly, you get these renal epithelial cells that trap fat. They're called oval fat bodies. One, a disease we'll talk about Thursday in nephrotic syndrome, a cast traps these they call them oval fat bodies, and it becomes a fatty cast. So think of it as the hyaline is your main cast and other things are trapped in it. That's how you get your other names. And just like we talked about size, squamous versus renal and transitional, then white, then red, then bacteria. With cast, you got to look at it this way too. A hyaline, it'll trap cells. It can be red, white, or oval fat bodies. The cells deteriorate and become a granular cast. The granular casts are still growing because you're not voiding them. When you have kidney problems, it becomes a big, broad, waxy cast. Remember, if you can think about how something progresses, it makes you more knowledgeable in your decisions on what you're calling. As far as what else causes cast to form, usually stasis, I'd circle that. If you're having kidney problems, usually you can't void properly. What were the terms you learned if you can't void the 1200 to 1500 mils? What were two terms that were less than that? Anuria is none. The other one began with an O. Yep, it's less than, either book said less than 400, less than 500. But if you're 1200 to 1500 mils is normal, and you're below 500, there's a good chance you're going to have stasis. That protein's going to accumulate into the form of a cast, and that cast can change as it sits there not being voided. Anytime the more acid, the more closer to 5, you have increased chance of cast. The specific gravity kind of goes hand in hand. If you have high protein, you're going to probably have a higher specific gravity. You're going to have more chance of the TAM horsefall precipitating out. They're usually only associated with the renal. So we talked about renal epies, cast or renal. It's definitely a kidney problem if you have renal epies or you have cast. That's a big thing. Always look for the rounded ends, because you'll see, if we get to see any mucus in class, they have the same consistency. Don't go calling it a cast if it doesn't have nice rounded ends. That'll be our rule of thumb so you don't overcall. And we'll go to 0 to 2 as normal. And that's just showing how it forms in the tubules. And it usually takes place, it usually takes place in the distal and collecting tubules. And then hyaline cast, you'll see with bright field, you've really got to turn your light down, especially when we do no stain. This is cylindrical ends. It just looks kind of granular and spongy. I always think of it as a soft gray sponge throughout. This is why you love phase. Phase, they kind of glow around the edges. And this is an example. If I can't see rounded ends here, it's hard to tell if this is a rounded end. I would have to call this mucus. If it has rounded ends, it would be a small hyaline cast. So our rule of thumb, you call and make sure they're rounded ends. This is actually a perfect rounded in there and a rounded here. You would wish everyone looked like that. They won't. And you gotta use your light source properly, especially when we do the urine unstained.
Is there a cell with that cast? That one?
It's hard to see exactly, but this is definitely There's no cells in here. If there's anything, it's all broken down. The cells should be distinct. Before you ever call it a cellular cast, you should be able to see them in the cast and outside free. So that's the other rule of thumb. Before you call a cellular cast, make sure there's other red blood cells, or you tested positive on your dipstick. There's other white blood cells, or you tested positive on your leukocyte esterase.
But they're huge, yes, compared to the cells.
Oh, the
Yeah.
casts are big, big. But the hyaline is very hard to see on our bright field scopes without adjusting your light. The cellular cast, little clues. I like to see, that's probably a free white cell. I like to see free cells around it. Like here, there's a lot of little red cells free. The other thing, sometimes white cells will look kind of yellow glowy on the inside. Red cells almost look brownish red. They kind of take an orangey brown stain color on a red cell cast, which are kind of helpful clues. And then epithelial cast, it's hard to find good epithelial cells because, because even I couldn't find a slide that had a nice free epi, but if you look at this closely on the computer, you can see most of these are single nuclei, and your white cells are mostly going to be 2 to 5 lobes. You're not going to have little single nuclei when you're talking about neutrophils fighting a UTI, okay? So think about that. If it's a single solid nucleus, it's probably an epithelial cell cast and not a white cell. So the white cell cast, if you can try, like here, there's a white cell, there's a white cell. There's a white cell, that almost looks like a red cell. Remember, as we do these, especially on hospital specimens, if you're going to call a cast that's a cell, look for free or look to make sure they had blood or white cells on the dipstick. So try to correlate what you're seeing cellular-wise to what it says on the dipstick. And then your red cell cast, like I said, a lot of them, like that's nice, there's a red cell, there's a red cell. It's kind of hard to, here's really 3 good red cells. There's a good ghost-like. Remember, your red cells are ghost-like, but they break down pretty quickly into hemoglobin cast. They just do. And remember I said this brownish, kind of reddish-brown color? That's very common with a red cell cast. So the color does kind of help you on those. Epithelial cell cast, like I said, these almost look like the high NC ratio epithelios. Remember the renals that have very high nucleus compared to the cytoplasm? But neither one I could find good cases. This has a big nucleus. Once again, these all look like single nuclei, which your neutrophils wouldn't be single nuclei. So that should give you a clue. It's not a neutrophil filling that. They're not white cells. But the epithelial cell casts are hard. So before I do anything and put an answer out that I wasn't quite sure, I'd say some type of cellular cast present, unable to determine which type. Especially if you didn't have high red cells or high leukocytes, then I might go as to say might be a renal. Okay? Remember, don't put out stuff that you can't back up. The granular cast, I don't make you distinguish if it's a fine granular or a coarse. But if we talked, it's hyaline traps the cells. You have stasis, the cells break down, they become granules. The granular casts get bigger because you're still not voiding them, they become waxy broad. So waxy broad are end-stage renal failure, where they can't void and they have anuria. Think about what each cell type or sediment means for the patient. If granular cast should tell you somewhere along the line they had a cellular cast that broke down. And these are very fine granules, and these you can almost see that there was some cells in here. That's a coarse granular. For me, all you gotta say it's a granular cast. And we most of the time could just put granular. We had choices on the computer for fine or coarse, bottom line, they're still granular casts. They still had to be cellular casts being broken down. I'm just a fan. If you understand what you're doing, you're going to make better judgments. If you know your sediment, know your cells, you'll make a better judgment at calling it. And a lot of your background has to just be memorization. Then as you start doing things, you build on that, okay? The waxy, this is, oops, sorry, I keep hitting the wrong thing. These notches are very common in waxy, but you see how they almost start squaring off. This one has a little rounded in there, but then it squares off. Both of these, and most labs are not going to distinguish. If you say waxy or broad, it's one and the same. Waxy is usually known for its little notches. We didn't distinguish them. It was the one and the same, and it's usually end-stage renal. They're not voiding. They probably have anuria or oliguria going into anuria. So when we talk about something like renal failure or chronic glomerulonephritis on Thursday, you're going to have one of the clues on the case study is that it has waxy or broad cast and very low output. And then other things that can be present under 40. So tomorrow, I'll be happy if we get through the 6 things. We look for mucus, we look for cast, we look for epis under 10, we look for reds, we look for whites, we look for bacteria. That you have to account for every urine. That'll be our goal tomorrow, to try to do 2 urines and look for that. So bacteria, this is someone who adjusted their light, that you can almost get it to glow back at you. So play around tomorrow, especially when we're doing unstained with your light, and sometimes the bacteria will kind of fluoresce at you. And that one, that's what that person did on this one. These are too hard to see the shapes, but this is more of a rod-like shaped. That's kind of more like a rod light. The little dots are more like cocci. Bacilli are the rod light. But remember, in the scheme of size, they are your smallest thing. So you're not going to say, oh my gosh, this big patch here, unless it's a big cluster. They're going to be small. And you've got to really lower your light on bright field to make them stand out. And it's very common when it's not clean catch to have some occasional bacteria present because you didn't have a clean catch. Ideally tomorrow, if you want to try to get your specimen right after your shower, so it's as best to be in more of a clean catch, then you're going to see less bacteria. And the yeast, the hardest thing, if they're by themselves like this, they're more oval than a red cell, but many times people can just think they're red cells. But you'll notice you didn't have any red cells positive on your dipstick, no blood, and we always kept a little thing of acid, like you could take acid from the hematology analyzer, keep it in a little bottle. If we were worried if it was red cells or yeast, when we were done looking at it, we take a drop of the acid and put it on it. If it was red cells, it goes away. Then you can say, oh, my 20 to 40 per high power field were red cells. They went away when I added acid. If they stay, you have to go with yeast. So remember, red cells and yeast can sometimes, that's why we like them when they're budding. And then these are all yeast, but they're called mycelial elements. When you get to micro, you have a mold phase that has these long strand-like projections of a yeast. And at 37 degrees, they're more little bodies at body temp. So all of this is yeast. And sometimes they call them pseudohyphae, the branch-like parts. And then the parasites, you're going to see, I don't know if you can kind of see these little flagella. Flagella are what give things movement. And you'll probably see more trichomonas in urines than anywhere. And you'll be sit there doing your micro, and all of a sudden you'll see this little cell going, and they're moving. And they look about the size of a white cell, and they'll move. And that's Trichomonas vaginalis. So I bet all of you will see it at your clinical site. And urines.
Isn't it an STD?
No, these are the little flagella up here.
No, isn't it an STD?
Yes,
Okay.
it is.
I remember questions.
Yes, trichomonas is potentially one. You're going to learn about syphilis in a couple places, immunology and micro. You're going to learn about HIV with, we have a neat little kit we do in immunology for HIV. Gonorrhea, you're going to learn about in micro. Some people get vaginosis, which isn't really an STD, but they have certain bacteria, one called G-Vag, that kind of takes over. And then chlamydia. When I was the guru of the fluorescent microscope back when I was in serology, so I have a fluorescent microscope here. I'm going to show you ANA still, but I also did chlamydia. So you got a ton of STDs that you'll learn about coming up.
Which one is that?
This is the trichomonas. This is the parasite.
What's the common name?
Trick. Trick is probably the most common thing it's called.
Yeah, trick.
Yeah. So this, I think all of you will see in your analysis when you're working on your clinical. And then mucus, this is phase, which makes it stand out really well. This is all mucus. It's just all throughout. I'd say this is more of a bright field scope. It doesn't look like they dropped the light enough. I think this is the true phase one, where it really stands out well. And that doesn't mean anything bad. Sperm, you're probably gonna see, phase is wonderful. It really makes it stand out, the dark background and the light. But they're pretty easy to tell in bright field too. Bottom line, drop your light tomorrow when we're doing unstained, which we're gonna do one of each.
I think the sperm are gonna be moving, right?
Depends on how fresh your urine is, if they're still moving or not. Not necessarily. If, a lot of things can still move if, I guess if you just had sex before you come in, and they'll be moving, but if
There's an excuse.
And these are very common. The air bubble, sometimes you'll see threads or clothing fibers. This is very common from our gloves. It'll look like reflective mirrors, little bodies that reflect back at you, and it's your glove. Sometimes glove particles, depending on the type of glove we're using. So you're gonna see a ton of this that means nothing. The slides we put it on are not sterile, so you're gonna get artifacts, okay? Especially when you're new, you think, oh my gosh, what's in my urine? And it's just junk. Okay, so I would recommend this before tomorrow. I'll show you what I have so far, that you can look at least 3 PowerPoints of sediment of, I already have 2 up, and then I put the 3rd one up even though I'm not completely finished. When I finish it, I'll just re-add it. But you can, there's sediment 1, sediment 2, right, that's right on a mixture PowerPoints, but if you go to course content, I also have, I had one that just, here, one that says pictures. And there's urine sediment 1, 2, and this is the one I just added that I have through normal crystals. I don't have all the abnormal crystals and all, but I would recommend looking at these 3 before tomorrow, just at your own leisure, where you can look at them on your own and go as fast as you want. But the more knowledge base you bring every time we do lab from here on out, you're going to do urine micros from here on out, even when we move to body fluids. Because I got to try to give you as much exposure as I can, and you've got to ask them. hey, I need to do as many urine microscopics. Because you're gonna get them fresh at the lab all throughout the day, whereas I only get what they have fresh that morning when I go before class. So, and there's no way to keep urine like you can keep blood smears. So we're kind of at the mercy of what shows up every day. Now what I do, this is how we're gonna work tomorrow. When we have class, I'm gonna assign someone to set up the machine. So I'm gonna just start at the front of the alphabet. So tomorrow I'm gonna have you set it up, and you can come in and practice a minute before you set it up. That will be your checkoff. Jen, you will be setting it up for Thursday's lab. So whenever we have lab, I'm gonna assign someone, and then we'll see how far we get, and by the end, you'll just have to do it on your own time sometimes until we get everybody through. So what you'll wanna do is clean it, calibrate it with the separate sticks, and then I'll have the controls out that you'll run the controls and put it all in the documented so we know it's been done. Then everybody, we're gonna do the full urine dipstick. We won't do the refractometer. Then you're gonna run your urine, and we're gonna put it on our key so everybody sees what was under the chemical part for each urine. Because that way you can correlate what we see under the microscope to it, okay? Sometimes I have a very good urine to look at, so I'll see. I'm gonna go do my urine now. And then Leah, you had, no, it was Nicole. He didn't, it would be, we could see if he has any bacteria proliferate, and we still want to check his glucose anyway. But you had some bacteria we want to see, and we'll see if anybody has anything. You know, the girls should at least maybe have mucus and squamous.
Do you want me to bring mine and my dad's, or just my dad's?
One of the days for sure bring your dad. Tomorrow just bring yours, and then maybe on Thursday. How about that?
Okay.
And then you know, as a heads up, for homework over the weekend, you're going to have to do the MTS on your analysis because it is really good.